Hello, everyone. Welcome back to another Cloud Launch and Learn session. Today we have Annie Talbasto. Welcome,
Hi,
Annie. How are you?
doing good. Happy to be here.
It's good to see you again. And for everybody who doesn't know you, Annie Talbasto is going to present today about getting started with Kubernetes. So before to start with Annie, I'm just going to let you know that you have to, well, it's good if you register your attendance to this session. And here in the screen, there is a QR code. So you can just scan the QR code and then you will register for this. And also this, it will allow you to get some material if you want to learn more a little bit about this topic, which is very interesting. So it's like a win-win. So don't forget to do that. I will put all of these links on the chat. So bear in mind that. So yeah, if there is anybody connected, let us know where are you at the moment and how are you guys. Before to hand over to you, Annie, I just wanna mention something else to the guys. And this is about the community Cloud Launch and Learn. We have another online event. It's gonna be on 4th of November, and this is it's called Ideaton. This is about a challenge for everybody who likes challenge, who likes like to keep learning. It's completely free, and this is about it's a challenge to develop a solution to improve the air in Bahrain. Sorry for my pronunciation, but that's the place. So I'm just gonna put all the information to in the chat. If you want to have a look, like it's a really interesting challenge. And another thing is like you can put this as experience in your CV, which looks great. You will learn, you will grow up your network. So it's like pretty much very good. Okay, so I'm just gonna put that information on the chat. And yeah, if there is nothing else for me, but are you ready, Annie, or you want to do something else?
No, I'm ready.
Perfect. So I'm just gonna hand over to you. I'm going to put your screen. So just a second. There it is. And I let you go, Annie. Okay. Enjoy your
Perfect.
session.
Thank you so much. Yeah, so let's get started. Um, First of all, I want to thank you, obviously, Cloud Lunch and Learn, and everybody involved in the community for letting me to come here and speak again about Kubernetes, which is a passion of mine. So very happy to be here and excited talking about getting started with Kubernetes in Azure this time. Really great. Let's get to my presenter deck area. Perfect. So, who am I? Why am I speaking about these kind of topics here? Why does this matter to me? And then what's my background? So, I am Annie. Nice to meet you all through these virtual lenses, as you do nowadays. I'm a product marketing manager at Cast AI, which is a Kubernetes cost optimization company. So I do Kubernetes as my day job as well. I am also a CNCF ambassador, as well as Azure MVP. I'm also a Kubernetes and CNCF meetup co-organizer for over 4 years now. I also coach early stage startups, as well as I do podcast called Cloud Gossip, where I'm the co-host and producer at cloudgossip.net. You can check it out. So super passionate about Kubernetes, cloud native tech, all of these things. Very excited to be here talking with you today. So what value do you get by attending this talk? This is kind of a for getting started with a session. It's very clear. You get to learn how to get started with so how to get started with Azure and Kubernetes together. So it's a great topic to be learning about, and that's the goal for today. And I think in general, containers and Kubernetes have well blossomed in so much in not even in recent years, but they keep growing more and more. It's a very hot topic, very interesting, very on-demand skill as well to know Kubernetes as well as containers. So here's some stats. So by 2020, this is a bit of an old stat, so obviously been that way already, but this is still valid. More than 50% of enterprises will run mission-critical containerized cloud-native application in production, according to Gartner. So it is very big in the enterprise scene already as well. Half of the container environment is orchestrated. And I will get to these terms a bit later because this is a getting started with session. So I will kind of take you through some of the basics first as well. So no worries if you're not understanding some of the concepts that I'm speaking right now. I will do a brief look into them soon. And the average size of container deployment has grown 75% in 1 year already, and larger companies are leading the adoption. So definitely containers are big, Kubernetes is big, and they're here to stay as well. But at the same time, it's very sometimes maybe not complex sounds a bit too difficult, but complex topic hard to grasp, maybe hard to get into sometimes. So this is a slide where so CNCF, which is Cloud Native Computing Foundation, which is the foundation behind Kubernetes, does a yearly survey every year where they ask, okay, what are the challenges that people are facing with using Kubernetes containers, all of these services, tech? What are the different techs that they're using? Are they using service meshes and so forth? So this is from there, from the CNCF survey. And so this is obviously a subset that's quite already in the Kubernetes world, so that they are willing to answer surveys for the Cloud Native Foundation and whatnot. But they have been asked, what are the challenges in using specifically containers? Please select all that apply for you. And the number one that you see there is complexity. So really, these things are not the easiest things to learn. So no worries if you're tuning into a getting started session and you might feel overwhelmed after it, or you felt overwhelmed before about these topics. These are big topics for everyone, so no worries if it's quite a lot. But the best way is just dive in and get started as well. And hopefully this session can help you with that. So as far as expectation management goes as well, so as I mentioned, this is a getting started session. So this is not a deep dive into Kubernetes and Azure or AKS or any of these things. It's not a technically zero to hero session, so it's getting started. I will start from kind of the basics and I will move on there. And that by I will give some kind of zero to hero tips towards the end, where you can kind of supercharge your Kubernetes as well. So no worries if you're looking for kind of different levels, but mostly it is relatively beginner stuff that I will be going through here today. So we will kick off with containers and Kubernetes. What does all of these mean? How did we end up with containers? And then we were going to go through 2 of the most popular Kubernetes services in Azure. And then we're going to, spoiler alert, go through AKS. Choosing one of the services to focus on. And then we're going to show next steps in Kubernetes. These are the kind of more zero to hero things that I mentioned. How to add on easy things that can make your Kubernetes experience quite a lot better. So it says demo Helm there, but I actually have prepared 3 demos today. Let's see how many we have the time for. We might want to kick it off with a Kata demo and then move on to the Helm and the Linkerd one. Let's see how we do on time, so we can decide on how many demos do we do today. So let's then get going as far as these go. So this is the structure of the presentation today. So if we imagine a scenario, so let's look into containers and Kubernetes first. So imagine a scenario where back in the day, or even nowadays, obviously, if they're not using container technology, if developers are in even the same location, they're preparing for a demo day, they want to showcase their application that everyone has to spend a lot of time building a new app. They want to show it to the world. They want to show it to all the other people in the demo day. And then everyone has developed the application in their own machines, and then they need to put it to the demo day machine. So this really means that it presents quite a lot of issues because these are not being isolated and whatnot. And it also takes a long time for example, if the file size of the application is big, the file transfer might take quite a long time if you want to move it to the demo day device. And obviously, if you are not in the same location, so like you can You can help by doing a physical transfer, just like taking the device and whatnot. But sometimes that's not an option if you are not within the same country and whatnot as well. So in general, these kind of scenarios are actually surprisingly tricky. And really what this means in a nutshell is if an application has been built and is used in another system, it might not function properly in the new environment that it's not built for. So what's working on your machine might not work on another person's machine, or in the demo day machine, for example, in this little very brief story that I said there before. So why does it kind of happen? It's kind of the same way as if an athlete trains in a high altitude environment, then they might not be able to exercise the same way in a low altitude environment then at the same time. So it requires some steps. And the solution there is virtual machines and containers. This is the way this has been quite widely fixed nowadays. So all in all, developing software for servers involves dealing with many problems. So like these kind of things, servers are expensive. You cannot have more than one operating system, and having multiple applications in one server can make them all fail, since they might not play well together. So this is where you need isolation and resource optimization. So in here you see, with just virtual machines, you have the infrastructure, and then you have the hypervisor, which is a computer software, firmware, or hardware that creates and runs virtual machines. But then again, the operating system is again individuals then. But then if you move to the container, you're using a container engine, and on top of that, you're running all of your apps. So you're adding another layer there so that everything runs smoothly. So you can kind of think as virtual machines as there are boxes, and then you can kind of put things into boxes, and then you can put things into boxes so that they work together very well. So the benefits of using containers then, you can use them with any operating system, you can use them anywhere on premises, on cloud, any app, monolith, microservice, any language as well. So containers are smaller than virtual machines because they don't include any of the unnecessary parts. So containers are typically 100 times smaller than virtual machines. So this makes them more portable and efficient. So if in the demo day example, if the applications had their own isolated boxes known as virtual machines to run happily in, there wouldn't have been any negative aspects from using these the apps in the same way. So with the containers, on the other hand, the demo day teams wouldn't have to worry about the slow transfer times or doing a physical transfer of the app either. So all in all, containers enable developer productivity and really help to build software faster as well. And Docker is usually the de facto container engine as well. There. So then we get to the Kubernetes part after that very brief intro into virtual machines, containers, and why these kind of things are important. So you get to the Kubernetes. So when you have all of these containers and you're trying to run them and it's all working very well, everything's isolated, all of your apps are working together, you don't have not my machine problem. But then if you have quite a lot of containers, you might end up with a situation that you have quite a lot to manage, and then you might be spending all of your time managing containers. So then you need container orchestration tooling, which is then, for example, Kubernetes. So Kubernetes was originally developed by Google. Nowadays, it's an open source project, and so everyone is contributing to it. It's under CNCF umbrella. It's very vendor neutral, and everyone is welcome to be part of the community as well as to build Kubernetes together. So that's really lovely as well. So it really helps you manage containerized applications. So and these kind of things are also connected to rise of microservices and therefore increased use of containers as well. So if you have a monolith structure, you have just one big thing working, and then if you have microservices, you just need more containers, and these kind of things really play well together as far as things go. So Kubernetes is an orchestration tool, as mentioned before. So it really provides high availability or no downtime, and it has really good scalability and high performance, and it has really good disaster recovery, backup, and restore as well. And really the kind of like, if you're managing a container or managing a bunch of containers with the orchestration tool, it really kind of goes to the cattle versus pet saying as well. So, if you're just managing one, you might treat it as a pet. You are, giving it a name, you're feeding it, you're petting it, all of these things. Kind of like if you have a dog, I have a puppy, I very much treat him very well. But at the same time, if you have a bunch of containers, if you have to manage a lot, it's more like cattle. So you can't, focus too much on individual thing. You have to focus on the whole cattle. So you have to make sure that like the whole cattle works very well, not just the individual within the cattle as well. Really quickly about the basic architecture of Kubernetes. So you have the control plane and the node, and the containers are inside the node. So the control plane is the kind of the mastermind, I guess. Essentially, each node has Docker containers, and that's where the work is happening. So the control plane is the one that keeps things running. So it has the API server, which is the entry point to the cluster. Then you have the controller manager, which keeps track of what's happening. Then you have a scheduler, which ensures pod placement. And then you have the etcd, which is Kubernetes backing store. So it stores how things look like. And then there's a virtual network between the control plane and the node. So nodes are bigger and they are running heavier loads, and the control plane is leaner, but the control plane is more important, since the control plane is the one who commands the nodes at the same time. Now that we have gone through kind of a bit of the history really briefly about containers, virtual machines, all of these things, now we have gone to the basic architecture bit of Kubernetes as well. Now we can get to the Azure part of things. So there are, I'm going to go through AKS and ACI here, which is great options for running Kubernetes on Azure. And within this session, I'm going to go through soon, give a few examples on what kind of things you can do at Azure with AKS, for example, but I won't be doing like a step-by-step instruction completely, because I think I will give you resources on where to find that next, because I think that's great to do on your own time when you have your computer, you have your setup, everything perfectly right in front of you, rather than, in this potentially hectic session that I'm doing here. So Azure Kubernetes Service, which is AKS. So it, as it says here, simplify the deployment, management, and operations of Kubernetes. So it manages your hosted Kubernetes environment and makes it simple to deploy and manage containerized applications in Azure. So it provides, you can deploy and manage Kubernetes with ease. You can scale and run applications with confidence, secure your Kubernetes environment, accelerate containerized application development, and work on how you want with open source tools and APIs. And you can set up CI/CD in just a few clicks. And I think I will be going through ACI next a bit, very briefly. So the key difference here, for example, is work on how you want with open source tools and APIs. So since Kubernetes is an open source tool under CNCF, there's actually quite a lot of great open source add-ons that I will be actually going through a few of them later on this session that you can use. You can pair it with AKS, which is absolutely wonderful, because you can kind of expand and supercharge your Kubernetes that way and get started way faster, to do more complicated things faster, and kind of dive deeper faster as well there. So the other one, as mentioned before, is Azure Container Instance, ACI, which is then easily run containers on Azure without managing the servers itself. So you can run containers without managing servers, increase agility with containers on demand, and secure applications with hypervisor isolation. And you can maybe just tell by the kind of feature list here that this is great service, but quite a lot more simpler. So if you're just looking for something super simple, obviously it works, it's nice. But then if you want to continue adding on, if you want to continue expanding, if you want to kind of take, leverage the larger community around these things as well, AKS does provide the kind of working with the open source tooling, for example, that you can kind of add on more as well. So that's really great as well. Let's do a quick save that everything is running very well. Perfect. And then let's get back to the presentation. So I will be going through quickly here AKS and how to deploy a Kubernetes cluster in Azure with AKS. So honestly, AKS makes deploying a Kubernetes cluster very easy and simple. There are other cloud providers, other services that also where it's just quite a bit more complicated out of the box. There are always usually tooling that you can use to help things and speed things up. But in AKS, the pathway is actually really nice and really good. So it's all essentially here. So you first off, you start by creating a resource group. So resource group is the logical group in which Azure resources are deployed and managed. So you do it with AZ group create. And then second, you create AKS cluster with AZ AKS create, a very powerful command here. So after a few minutes, the command completes and returns a JSON formatted information about the cluster. And three, you connect to the cluster with the AZ AKS get credentials command. And there's the command accidentally there. I have to remove it for the presentation. Sorry about that. But with this, you can then manage the Kubernetes cluster, use the Kubernetes command line client, kubectl. kubectl is already installed if you use Azure Cloud Shell. So you can configure kubectl as well here, and you can verify the connection to your cluster using the kubectl get command. So then this command returns a list of cluster nodes as well. And the last step is just to run the application that you need to run. So very simple, 3 easy steps here. Easy to describe in this way as well. So that's very nice as well to get you started. So there, you can also then how to scale a cluster might be a question that you're wondering. So you can see the number and state of pods with kubectl get pods, and you can then manually change the amount of pods that you have with kubectl scale, and then put the replicas number in. You can do the command there, and then if you want to use automation, you can use cluster autoscaler. I usually quite often recommend using an autoscaler and using automation, because I think if you're spending less time on managing little things and these kind of things, you can focus more on the things that matter most to you on your developing journey as well. You can verify with kubectl get pods as well. So then Azure Kubernetes service, how do you upgrade the cluster then? Part 1, part 2 coming up in the next slide. So you can use AZ AKS get upgrades to find out more about is there an upgrade ready. So you can see these kind of examples there, and when you can upgrade, you will see this example there, and if not, you will see the error table output unavailable. So can you upgrade or not? So then to upgrade, if you have a need to upgrade, you can use the AZ AKS upgrade from there and choose the Kubernetes version that you want. And check then if it worked with the AZ AKS show resource group command. And no need to write up any of these into notes, or just kind of take anything. I will link to you to a step-by-step guide by Microsoft in the end that you can use to do this step-by-step on your own time. And get started on that front as well. But these are just to highlight to you that it's actually very simple and it doesn't take too many commands to get you started as well. So if you are running into any issues, you can use AKS diagnostics, Azure Kubernetes Service diagnostics to figure things out as well, and help you troubleshoot the common issues that are happening there as well. And then now that we've covered kind of this is how containers work, this is how virtual machines work, then a bit about Kubernetes, and then now we've gone through, ACI is available, AKS is available, and that's how easy it is to use AKS. Just use these kind of simple commands, and then we get started on there. Then we can look into the greater ecosystem. What does this all mean what are the kind of next steps that you can take after you have handled I would say these are included in the basics already, kind of, that you can get started with, but the next steps after creating your Kubernetes cluster and getting started on that front. So just a bit about CNCF, I've already mentioned what it is. So it's Cloud Native Computing Foundation, which is building sustainable ecosystems for cloud native software. so it's CNCF is the short term for it, and it runs KubeCon, for example, which is one of the largest open source conferences in the world. It's part of Linux Foundation and whatnot. And CNCF houses Kubernetes as well as many other projects. And so what the landscape looks like this. So this is all the different parts of CNCF. This is the cloud native landscape. It's quite a lot. There's so many different parts, and this is what I mean that the power that you get with AKS. You get access to so many different resources, so many different add-ons. You get so many new open source projects that you can really use to upgrade your Kubernetes as well. So that is a really lovely way to get started there. But this is a very complicated view. This looks very baffling maybe at the first time if it's your first time seeing this landscape. So then I usually try to kind of break it down, but like, don't worry about this landscape. It's quite big, but let's look at individual projects that Helm can really help you kickstart and get you started by using Kubernetes in a lot more efficient way as well. So we're going to look at into a few projects today. So we're going to have first look at Kata as well. So I mentioned Kubernetes Autoscaler. I mentioned automating that as well, which is super important if you want to actually focus on things that matter to you. So default Kubernetes scaling is not really well suited for event-driven applications. And Kubernetes is more for resource-based scaling, for CPU and memory. Then Kata is actually event-driven scale controlling that can run inside any Kubernetes cluster, and it can monitor the rate of events to preemptively act before the CPU is affected. And you can install it into new or existing clusters, and it has extensible and pluggable scalers to grab metrics from multiple sources. And this is the kind of nutshell version of what is Kata and why is it used. And this is an example. I will have a few more examples as well. This is an example of a project that you can really use as an add-on to your Kubernetes, so that then you don't have to worry about auto-scaling applications anymore, which is really nice in my opinion, at least. So then just quickly, I'm going to run through to a demo, which is Kata scaling .NET Core Worker with Azure Service Bus. So here is the architecture of the demo app. It's very abstract in this image, but you can actually just imagine that the demo itself is essentially a web shop. So let's say, Halloween is coming up. I would have a web shop that's selling Halloween masks, and I need to, Halloween is coming. Everyone wants to get their Halloween mask. We need to get, we will get a bunch of orders at the same time, and we need to process all of those orders. So this is what it means that, you have order processor that processes all of the orders, and the orders are in a queue. We will see what happens when a lot of orders come in at the same time. So let's get kicking with the demo as well. You can see here, let's get my notes as well. I need always notes. I have the biggest scatterbrain if I didn't have. So let's get started. You can see the demo there. Let's hope that the demo gods are with us and nothing will go wrong. So we can do kubectl get services namespace Kata to get the external IP where we'll see actually the orders come in there. Then let's do let's actually do, there we go. Let's kick it here. This one was open for this. And then we see here the order queue length. We see number of messages, we see order queue, and we will see them coming into here. Let's open up the correct terminals here. So then we will get to kubectl. We will do kubectl get deployments namespace here, so that we see how many order processors we have ready and how many are available, so that soon we will actually start needing quite a lot of them, because as I said, we are running a Halloween mask shop and we expect a lot of orders coming in soon. But before we get to see all of those orders rushing in, we can go here and do kubectl get boss namespace Kata as well here. so that we see on what's the kind of the history of what's happening here. Let's make this actually a bit smaller so that we see at the same time. There we go. Then we will get to the actual demo part now that we've prepped everything wonderfully. So we do .NET Run project. I did this for my KubeCon session. So this is why the demo is called KubeCon demo. So you will see quite a lot of action soon. There will be a lot of things happening. You will see orders coming in. You will see Kata kicking in, starting the auto scaling, all of these. So these the orders are events that are happening, and then we're doing the auto scaling based on these things as well. And then we do this, and then it's going to ask us, let's queue some orders. How many do you want? And we want 100 orders in. So we see 100 orders of soap for Rick, tuna, fish, hat, bite. Now all the Halloween masks are flying out of the shelf. We see here order processors are getting kicked off. We see order queue getting higher and higher and higher. We see here actually that there's a container pending container creating. We see the order queue still getting higher because now the orders are here finished. But now it's actually getting lower again as well. As I said, it's very fast. So the orders are processed very fast. Here is pending container creating, and now it's mostly to the running phase here. We see 10 out of 10 order processors working as is. And now we see the order queue has gone down. So we have actually now processed all of the orders that came in that fast, and that's all automatically. So we had a bunch of orders come in. Kata handled our orders in a way that it scaled us up, and soon, well, not quite soon. It's going to take about 5 minutes in this demo. So then the Kata will start scaling down as well, which is absolutely wonderful as well. So it doesn't just scale up when needed; it scales down when needed as well. So this is a wonderful add-on to your Kubernetes. So Kubernetes itself doesn't do this quite well. So then you can use this to really handle things automatically for you as well. And so in KubeCon, for example, I also spoke about the environmental impact of all of this. So you can imagine that if you are running your cluster with Kata, for example, and using event-driven autoscaling, you're actually also managing your cloud waste and the natural resources that you're using in the most wisest way possible, because you're not wasting any resources, because you're auto-scaling up and auto-scaling down whenever you had that need actually present itself, not constantly, running on over provisioning or anything like that. So that's where we saw these parts. It's going to take, as I said, 5 minutes for the to start terminating. So we're going to get back to it a bit later as well. And we're going to go through some other things while that is working on the background. And then actually, if I have to do the next demos, I will have to switch clusters, but it's okay. We will manage. You saw most of the action. You saw it go up, and now you saw it go. You would see it going down, but it's essentially just terminating, and it all works very nicely as well. So these kind of things you can get if you're using AKS, for example, because you can add on these really cool open source tooling. And then another one that I highly recommend using, very kind of getting started material as well. So Helm. Helm is a CNCF project as well. So Helm is a package manager for Kubernetes. So it's kind of like Homebrew, Snap, or Chocolatey for Kubernetes. And I think one of the Helm maintainers really put it well. So package management is tooling that enables someone who has knowledge of an application on a platform to package up an application so that someone else who has neither extensive knowledge of the application or the way that it needs to be run on the platform, so that they can actually use it as well. So this is the power of package management and the power of Helm as well. So Helm helps you manage complexity. So Helm is used by charts, and charts can describe even the most complex apps. It can provide repeatable application installation and serve as a single point of authority. It has easy updates and it takes the pain of updates with in-place upgrades and custom hooks, and it has simple sharing. So it means charts are easy to version, share, and host on public or private servers. And it has rollbacks as well, so you can use Helm to roll back to an older version of a release with ease as well. So Helm is, as mentioned before, is used by using charts, and the prerequisites are just having a Kubernetes cluster, deciding what security configurations to apply to your installation, if any, and installing and configuring Helm, which is a good start as well. So now I would have a Helm demo that's also kind of good Kubernetes demo as well, which I will show you how to easily deploy a complex application, for example, WordPress, to Kubernetes using a Helm chart. So now we should get here, and actually, yeah, I forgot to show this. So this is the area where would you usually have, it's for Kata, this is where we usually have how many replica sets are needed for your YAML. But then in here, you actually see, so here, so you see that the replica count isn't set, so it's just the minimum replica count and max replica count there. But that was for Kata, the sidetrack there. So it still hasn't terminated. It's still up and running, but it's okay. We can actually just terminate this and then do a switch, a quick switcheroo. If I can get through this very smoothly. We're gonna switch to my other cluster so that we can get to the Helm demo as well. So you do that with the AZ AKS get credentials command. So let's get kicking off with the Helm demo then. So we do AZ account show. We see here Azure is running very well. Once again, well, you saw it earlier again a bit as well. So with kubectl get services, we can then see that there is a Kubernetes cluster that's empty and it's running very well and it's all good there. So then if we do kubectl get services all namespaces, we actually see that there's a lot of Linkerd stuff as well. I have a Linkerd demo as well that I can do. So that is by that, but for the purpose of this Helm demo, it is empty because there isn't anything. Because we can also do Helm list, so we can see that there is no Helm releases either at the moment. Sorry, I clicked on the Bitnami chart there because the next command has a this here. So we can do I did not include the H there. This is what happens when you're trying to do multiple demos at the same time, even if the demo gods aren't hindering you, yourself will hinder yourself. So you can do Helm repo add Bitnami. So for me, it doesn't do anything, but for you, it would then add the Bitnami there, but I've done it before. So that's why it's just saying to, skipping it. So we can do Helm search repo WordPress. So it's going to find out if there's Helm releases available. And yes, there's the Bitnami WordPress that we do want. And then if we plug in Helm install WordPress generate name, this is where we get to the magic happening. So this is the actual command that gets us started. So we have a lot of new stuff here coming in. So we can get it started. It takes a while for it to sprung up, but we can actually get the external IP already. So we can go to kubectl get services, and we see here the external IP is ready. And then we grab it here. We go here, and then we plug that here because we don't need the order queue length anymore. It's not opening up yet because it takes a while for the WordPress to appear. But no worries, we have stuff to do meanwhile, because now we don't just want to create the WordPress. We actually want to get to the next steps, which is, using that WordPress site, is accessing that WordPress, and getting started if we want to like build a blog, for example. So we need to get the admin credentials, for example. So then we will get these by taking the echo password here, because Kubernetes has already provided them with us. So we do this here. We see the password is this here. We can copy paste it to safety. So here, and then we see echo username here. We see the user is the user for our wonderful upcoming WordPress, and then the password you get from here, and it's here. So we should see it opening up relatively soon here. But while we wait, so what has actually happened? Oh, so here it goes. Immediately, whenever I say that it should be coming up soon, magically it appears. So what has happened here altogether? We've installed WordPress and MariaDB to our Kubernetes cluster, configured WordPress, and stored the admin credentials securely as Kubernetes secrets. So now we can actually go and access this. We have it there. Too many typos today. So we can then, as you saw earlier, user is our username, and then we put password, the one that we found from there, and not now for saving the password. And there we have it. We're already in and running, and we can start writing on our WordPress amazing blog. So that's how easy with Helm it's to install a complex application on top of your Kubernetes. So these are the kind of things that, if you sometimes feel that Kubernetes might be complex to get started, you can just, if you're using AKS, you can plug in Helm, and running things is quite a lot easier than it was if it would be just using Kubernetes out of the box as well. So there is quite a lot that you can do with these kind of things to really supercharge your early on Kubernetes use as well. Yeah, so then getting to other services that I really recommend, which is Linkerd. So it's a service mesh. It's ultra light, ultra fast, and security first service mesh for Kubernetes. It's really good for in general, and it's the first service mesh that was around, and it's a CNCF project as well. So it's one of these open source projects that you can use to really supercharge your Kubernetes use. And the overall goal is to reduce the mental overhead of having a service mesh. So what does Linkerd and a service mesh do? So it provides observability. So it gives you service level important metrics, success rates, land latencies, etc. And it provides you with reliability. It gives you retries, timeouts, as well as security. So having a service mesh is super nice. So Linkerd, the other benefits are kind of that you have that it's a thriving open source community that's always willing to help you and get you started along your way. It has a simple and very minimalist design, so no complex APIs or configuration. It has deep runtime diagnostics, so you can get a comprehensive suite of diagnostic tools, including automatic service dependency maps and live traffic samples. It's ultra light and ultra fast, so it's built in Rust. Linkerd's data plane proxies are incredibly small and very fast, and it installs in seconds with zero configuration as well. And Linkerd's control plane installs in a single namespace, actually the namespace that I showed you in earlier as well. And services can be safely added to the mesh one at a time. And it has this actionable service metrics that I mentioned before, for example, success rate, request volume, and latency as well. So using Linkerd is super simple. So you can just use this, inject this, and then you're essentially good to go. Again, making complex things easier as well is really great add-on for all of these projects that you can use with AKS on top of it. I do have a Linkerd demo that I think we do have the time to run as well. So this is the demo app that I will be showing you. It's a Linkerd demo app. So it's easy real-time service metrics to get you started on your service mesh journey. Let me check on if there's any questions before we jump into the demo. Good. Yeah, I can give you the link to the survey later on. And I will actually give you a link to a hands-on lab towards the end as well, so no worries there. But yeah, let's get to the Linkerd demo. It's going to be a relatively fast one as well. Let's see. Let's find. let's find the notes here. So let's clean house a bit. Let's turn this. We don't. Then let's kick things off here. Let's open up a few more. Let's do this one here. So you don't need to see this one very well, so that's why I'm making it to the small one. So if we do kubectl emoji voter port forward here, we see everything working. And there we go. And now, of course, I need to have this. So this is the app that we're going to be showcasing. And that's why you didn't need to see that too much. So it's a very nice app that you can use to vote on your favorite emojis. So we can vote for the laughing sway, laughing, crying face one. We can vote for the dollar one, for the ghost one, and whatnot. And then if you click on the view the leaderboard, you can actually see there's quite a lot more already votes than the ones that I just gave. So there's a lot of stuff happening in the background. There's bots voting. And to get us visibility into what's happening while the bots are voting, we can, for example, do Linkerd emoji vote top deploy here. So that here we see all the bots, they are voting away, a lot of things happening. These are the kind of info that you get with Linkerd as well. So then if we do Linkerd dashboard, we can actually see another view into this. Let's see. Oh no, I think I need a new. Let's grab grass. Oh, Linkerd dashboard. There we go. Perfect. So you see all of this happening here in this terminal, but we can actually see a lot of the same as well as similar metrics in a lot more graphical way in here. So in here you have, you can see the namespaces, you can see success rate, you can see latency, you can see all of these things. So for example, you can go to here and you can click Mojivoto and you can click start and you can see quite a lot more data here. Success rates again, count, best. You can go to tab as well. Emoji will go start. You can see again a lot of new info there as well. And then you can click to here actually the Grafana logo, and there we get to Prometheus, and then we can see global success rate, a lot of these things. This is very like just out of the box, everything working super easily, very light, very easy to use things as well. So this is really the great part about Linkerd as well. As mentioned before, it really helps you get started so that the complexity of Kubernetes doesn't kind of attack you too much. Obviously, it gets complex if you're using a lot of these services as well, but at the same time, it helps you get faster to the direction that you want to go to. But obviously be mindful of all the add-ons that you add so that you don't end up in a situation where you have a gazillion of them and you don't know what you're managing anymore, like a monster. But that's okay as well. I always love talking about these projects, so the more the merrier, I guess. So CNCF helps you along the way as well. So if you're wondering like, okay, what of these projects should I be using? Like, what should I be using out of all of these things? This is too much. There's too many of these because this is just the tip of the iceberg. There's like 40, 50 more just under the CNCF umbrella itself. So there's the cloud native trail map that you can follow. You can, kind of start from there, and there's a recommended service. So you can see here, for example, in the 3 orchestration application definition, Helm is a recommended service there. And then on the 5th part, you can see service proxies, discovery, and mesh. You can there see Linkerd is a recommended project. So like you can see that you can just kind of walk this trail and bit by bit discover more services. Some of the ones that I've showcased you today as well. So no worries, there's always more resources on getting you started into these as well. Then quickly, if you learn more resources, as I promised. So here are links. No worries to kind of get too stressed about this. So I will add the slides to my GitHub, so you can access this learn more slide from there as well. But here I first linked all of the different guides that I was showcasing you before with from Docs Microsoft that you can use to kind of walk through all the different commands that I showed you before. And then a really good workshop, you can actually find it from this address. I ran it before while I was working at Microsoft. I was running this workshop for people, and it had really good reviews from all the people that I ran it with, very beginners usually as well. So I highly recommend the AKS workshop. It might not be super discoverable with Google or Bing, so you can actually take that and write the exact address to your browser, so you can access it as well. But as said, I will add these links to and the slides to GitHub as well, so no need to worry about things too much if you miss your opportunity to take a picture or write this right now. So CNCF in YouTube has also a lot of good materials that you can use to learn more about these things. There's usually really good getting started with Kubernetes session. Every KubeCon, there's usually a track of like beginner sessions that you can watch through, and they are usually compiled as a playlist YouTube as well. Highly recommend that as well. I'm always in CNCF YouTube just watching these sessions. It's really great. KubeCon North America finished 2 weeks ago or so. So there's going to be a lot of fresh content coming up soon when all of those sessions will be added to YouTube as well. Another great YouTube resource is Tech World with Nana, a really wonderful YouTuber going through a lot of the different cloud native Kubernetes topics from a very approachable way. So I highly recommend those if you're looking for like guidance along with your workshop or step-by-step guides to walk you through on how these things are used as well. And as mentioned before, if you're interested in these topics as more, I host and produce the Cloud Gossip podcast, where we, for example, interviewed a CNCF project, Kata actually, Kata's maintainer. So he went more into, okay, what does it mean to be a maintainer for an open source project and all of these kind of things. So if you're interested in those, I highly recommend checking Cloud Gossip out as well. But that's it from me today. I hope the kind of brief history about everything, then some of the commands and few projects that you can add on to your Kubernetes were helpful. And I highly recommend checking through the workshop as well as the Microsoft documentation, obviously. But the Learn workshop is really great step by step into how to deploy your first Kubernetes cluster and get started on that front as well, to take on your own time to follow everything by step by step. But yeah, as mentioned, I will add all the slides and everything to GitHub. So looking forward to that. And if you have any questions after this, you can always reach out to me on Twitter or on LinkedIn or whatnot. So always happy to help people out there as well. Yeah, that's it from me for today.
Perfect. Yeah, thank you so much. That was an amazing presentation as always. That's really a lot of stuff to learn. I cannot see any more questions in the chat. Only Agam. I don't know if I pronounce properly, but this Agam, the comments that he put on the chat.
Yeah.
But I think you already mentioned about it. But no, apart of that, there is no. I have a really quick questions. I know we have just a few minutes left, but when you were talking about design your solution, is there any recommended number of pods to create when you are, developing your Kubernetes?
I think there's usually best practices for different scenarios and whatnot, but I can't give like a overall like super okay like fit size for everything kind of recommendation here. So yeah.
Okay, thank you for that. Well, I think there is no more questions. Just thank you guys also in the chat, because I saw people very excited from India, from Netherlands, from UK, from Dublin. So it was really nice, to see people around the world. And just remember to register to this session. So here is a QR code and the link if you want to get more materials and keep learning. And so yeah, that's pretty much everything. Oh, and one more thing before we go, it's just remember about the ideathon, the thing that we mentioned at the beginning. It will be really nice if you register and participate. It's a really good challenge. So just don't forget about that. And I'm gonna put the links on the chat too, and that will be everything from me too. So if there is no more questions and any more that you would like to say, so just to say thank you so much for everybody, and thank you so much, Annie. It's really good to see you again. Thank you so much for this amazing presentation.
Of course, I was super happy to be here and nice to see you again, as well as the whole community.
Thank you so much. So see you then, guys, and have fun for the rest of the day. Thank you.